Hi, my name is Elise Varga. I'm in Group 2, and for this project, my group decided to analyze student alcohol consumption. The reason we chose this data set is because aspects of student life are very prevalent with us, and we were curious to see the impact of alcohol consumption on students' lives. The data from this data set came from 395 Portuguese students from 2 different schools and all different grades and ages. So these are questions that we wanted to answer with this project. Which gender consumes more alcohol? Do students who want higher education consume more or less alcohol? Do students who fail more in school consume more or less alcohol? Students who spend longer time studying consume more or less alcohol. How does the level of alcohol consumed affect final grades? And how does the number of absences affect final grades? So for our main script, we first loaded the data, and then we began with a while loop, which keeps the menu going after the user is done with each option until the user chose to stop, in which case all graphs close. We use a menu so that the user can choose which topic they'd like to learn about, and in this while loop, we use if-else statements to represent each of the options depending on which choice the user makes. After that, we convert the data we extracted from cell arrays, which we then use as input for each of our functions. Within each if statement, we use while loops in which we ask a question pertaining to the topic chosen. The user inputs the incorrect answer. The loop continues by repeating the question until the correct answer is input. Then the function is called, and depending on the option the user chose, different info or graphs will appear. These steps were implemented for every option on the menu. So next we have our gender function. For this function, our inputs are the data for gender and alcohol consumption levels, and our output is A, which is a matrix containing the number of male and females at each alcohol level. First, we initialize the counter variables, which is the individual's gender at each alcohol consumption. We then use a for loop and switch cases to go through all the rows of alcohol consumption and check whether the person was a male or female at each alcohol consumption, and add 1 for every applicable variable. After the loop runs, we know the amount of alcohol males and females consumed. Then we combine the number of females and males at each alcohol consumption into a matrix in order to plot a bar graph. In this graph, we can see that females consume more alcohol than males, which answers our first question. So if you run the main script, so here's the bar graph that shows that females consume more alcohol. So our next function is the higher education function. This function accepts yes or no answers from the data to whether people want to pursue higher education and compares those answers to the amount of alcohol they consume. Our output was a matrix which contained the averages of yes and no responses at each alcohol level. To begin, we initialize the yes and no responses at each alcohol consumption, then use for loops and if statements to check the amount of people who responded yes or no at each alcohol consumption. We found the total amount of yes and no responses and created a pie chart. Also, we plotted a bar graph which shows the average responses at each alcohol consumption and the weighted average of alcohol consumption for each category. The results show that people who do not wish to pursue higher education consume more alcohol. So if you go back to the menu, here's a bar graph that shows the weighted averages, and here's the pie chart that shows that 95% of students responded yes to pursuing higher education. So next we have the failures function. This function analyzes the relationship between past class failures and alcohol consumption levels. Its input is the failures and alcohol consumption data. This function uses for loops and if-else statements to loop through the data and calculate the number of each combination of failures and alcohol consumption. This allowed us to graph the data in a logical way and calculate the correlation coefficient, which is the output. The plot we used was a 2D plot. We chose to graph the counting variables because when we graphed just the raw data, there was no information or conclusion that we could draw from the graph. So by plotting the counting variables, we were able to see the most common combinations of failure and alcohol consumption. The results of our calculation show that there is no direct correlation between these two variables. So here's the graph that shows the frequency of each combination. The next function we have is study time. For this function, we compared study times and alcohol consumption. The inputs for this function are study time and alcohol consumption data. Similar to the failures function, we created separate variables for each possible combination right here and initialized them to 0. Then we used a series of for loops and nested if-else statements to go through each point in the data and add up the values for each of the 20 combinations. We then graphed each study time in a 2D plot in a different color so that the user can see how the number of students consuming certain amounts of alcohol fluctuates over a study time interval. We used for loops to label each portion of the graph and created a legend to make it easy to comprehend the data, in addition to a description in the command window. The output of this function is R, which is the correlation coefficient in the data graph. The results show us that the students who study more tend to have a slightly lower alcohol consumption. Here's the graph with the legend, as well as the graph explanation that explains the code, the labels, and the correlation. The next function that we have is final grades, and that is combined with the plotting final grades and absences, so I'll describe them all first. So for this function, we used the final grades data and alcohol consumption data as our inputs. Our output was G, which is a variable containing the sorted G3 matrix used as the input for the next function. We begin by initializing variables for alcohol consumption and final grades at each alcohol consumption. We used a for loop which went through each row of the alcohol consumption and added the grades which corresponded to each alcohol level, and used these variables to find the average grades at each alcohol level. After that, we created a table which displays the average final grade at each alcohol level. We ended up by sorting final grades to use it in our next function. Based on our results, there's no direct relationship between final grades and alcohol consumption. Now we'll look at the plotting function for that. For this function, the inputs were G, the output from final grades function, R, which is a question answered in the main script, and student mat, our data set, and final grades, which is used to get the output for the next function. This function takes the sorted grades from the final grades function and uses it to plot a histogram showing the final grades that people got in this class from 0 to 20. Also, with the input of what grade people wanted to learn about, we used a while loop, which finds how many students got a certain grade depending on their inputs and prints the results. After that, we extracted absences from our table, which we're going to use for our next function. And then the absences function. This function compares absences and final grades. It takes the data that is extracted at the end of FG plot as its input, as well as the final grades data. This function first outputs a scatter plot of the data. We then use polyfit and polyval to graph a first-order curve to fit the data. We also calculated a correlation coefficient for the data and displayed that to the user with a description which helped to understand how to interpret curve fit and correlation coefficient. Next, we prompted the user to enter a minimum bound of the data and a max bound of the data. We then used a for loop to plot the data based on the parameters given, as well as calculate the minimum grade and maximum grade within those parameters. The output of this function is the values for the min and max grade in the interval. Based on our curve fit and correlation coefficient, there is no direct relationship between absences and final grades. So we'll go to the main script and start with running final grades. So here's the table for final grades that's output with the labels up above. We'll do 13. So it says the number of students who got 13 are 31, and then here's the histogram that shows the frequency of each grade. And then this is the scatter plot of the absences and final grades with the first order curve fit. As for a minimum number between 0 and 75 to the 12, maximum number 57. So here's a plot that is just within those bounds. And so it says the highest grade in this range is 18, the lowest grade in this range is 4, and then it gives the explanation for the R value and why there is not a correlation that is seen. And that's it for the program. So in conclusion, I learned a lot about MATLAB through doing this project. Before this, I really only had worked with 2D plots, and so now I feel comfortable working with bar grams and histograms and pie charts and tables even. And so I also had a really good opportunity to do more logical indexing, so I understand that a lot better, and just to see how much loops improve efficiency with looking at large groups of data. That's it.